Okay, this is our lesson on solving inequalities, and we're just continuing this in Chapter 7 in addition to our solving systems unit. So this is taking us way back to, boy, probably about 7th grade when you first learned how to graph inequalities. So we're just going to do a quick recap on them. This symbol means less than, so wherever you decide to start your number line, I just put a 0 there. You could just put the 2 there if you wanted. We'll put a 0 or an open circle on 2 because a less than means only an open circle. It's not filled in, and we're doing everything less than 2, so we're going that away. Next one says x is greater than or equal to -1. I'll just throw a -1 on there. This time the circle is going to get filled in because we are greater than or equal to, and that equal to means we're going to fill in circles, and then greater than things would be on this side of -1. Hopefully this is just a really fun, maybe not fun for you, but maybe just a really easy review. Then we've got kind of this compound statement where we've got numbers on both ends of the x's, and we need to graph both of these numbers. So I'll throw a 0 on there, and we'll do -1, and then we'll do 2. And both of them have open circles because they are just less thans, they are not equal to's. And then I want all of the x's that are between them, so this is where I want to shade. The next one says or. This is more of an and statement. I need everything that is greater than -1 and all of the things that are less than 2. So you kind of want that space in there. This is an or statement. I could have any of the things that are less than -2 or anything that's bigger than 1. So I'll throw my 0 on there again. Here's 1, open circle, and I want everything that's greater. And then -2 would be right here, closed circle, and I want everything that's less than. So we could have one where you have your 2 boundaries and then you fill in what's in the middle, or you could have 2 boundaries and then kind of going away from them. So we're going to do some that are solving, and then you're going to graph them. So first you're going to need to solve for x, and then we'll plot them just like we were doing before. So I'm going to divide both sides by -3, and hopefully you remember when you divide by a negative that you have to flip the sign. So x will now be less than or equal to 14/3. And then we'll just turn that into a decimal real quick if you want. Sometimes it's easier for people to solve when they see the decimal instead, which is fine, or you can graph it as fractions. So I'll put a 0 there, and then 14 divided by 3. Sorry, I was going to grab my calculator. So I can get the decimal for you. It's about 4.6. So I'll graph something around there. 1, 2, 3, 4, 5. 4.6 is right about there-ish. And then we are filling this one in because we are less than or equal to. And then we are looking for everything greater than that. Oh, sorry, that was greater. This is less than. What we solved was less than. So we want to go that way. Next one. Now I've kind of got this weird compound situation where I've got numbers on both ends and some stuff in the middle. And we're actually going to solve that as though they were kind of like 2 different equations almost. So when I have this setup, what I'm going to do is kind of like just treat these like they're 2 fence problems. So you could think of it as like -4 is less than 6x minus 10, and then you also have to do 6x minus 10 is less than or equal to 14. So you could kind of treat them like 2 separate situations. I'm just going to solve them all in one setting. So what I would have to do initially in order to solve for x is to add 10. I just need to add 10 to both ends. I can't just do it in one spot. Like I said, you could go over here and solve both of these independently and then graph them. I'm just going to kind of do it in one shot instead of separating them apart. So over here I'll get 6 is less than, and now we're at 6x, and this will be 24. And now I divide both of these by 6, or everything by 6, and I'll get 1, and we're going to 4. So I'm going to throw my 0 in there. Here's a 1, open circle. Here's 4, closed circle, and I want everything in between. Next up, we're going to do some absolute value, and they change things up just a little bit in terms of how you solve them. So the whole point of absolute value, well, the whole idea behind absolute value is you're talking about like the space, or how many spaces or units away from this number you are. So absolute value turns everything that's in there positive. So what you're talking about is distance with absolute value. So you're trying to figure out all of the values that would be 7 units away from 5 on the number line. So what we want to do is set up two different things that could happen. We've definitely got this equation that could happen. And the other thing that could happen is it could be a -7. So this stuff in here, even though absolute value will turn it positive, that expression, that x minus 5, could be both +7 and it could equal -7, because then when I put it into the absolute value, it's going to make it -7 no matter what. So those are the two things that could happen. Almost like saying when we do x squared equals 9 and we solve that and we get plus or minus 3, because it could be +3 getting squared to get to 9, and it could be -3 getting squared to be 9. So you've got to have one expression that is 7 and then one that is -7, because either one of those, if I absolute value them, will be +7 in the end. So subtracting 7 here, I get 2. And then adding 5, I don't know why I said that, add 5 here, you'll get 12, my bad. And then adding 5 here will get us -2. A little struggle there, I'm trying to do too many things at once. So now we just need to graph both of these values. So I'm actually gonna go by 2's, because to get all the way to 12, I don't have enough little tick marks. Ooh, I don't know if I go by 2's either, we'll have to add a line. So 2, 4, 6, 8, 10, 12, put a dot there. And then -2 is your other possible value, so we'll put a dot there. Both of those, if you were to put a 5 down, they are 7 spots away, 7 units away from 5. So that's what you're trying to find, is what is 7 units away from 5. Let's try the other one, just increasing difficulty a tiny bit in your solving. So the two different things that could happen is that the 2x plus 12 could be 4x, and the 2x plus 12 could also be -4x. So either one of those could end up working because of the absolute value. Remember, it turns everything positive. So solving each of these individually, we'll subtract our 2x over, and x is 6. And then we'll subtract our 2x over, but this time we get -6x, and then our x is -2. So those are the two values that we've got. What you want to do is you need to check and see if you have any extraneous solutions when you're doing absolute value. Just like up when we were doing these types of things, depending on the problem you're using, one of those might be an extra answer that doesn't actually work. So we need to check and make sure that the two answers we got when doing absolute value actually come out to work. So I'm going to try the 6 first. 2 times 6 is 12, plus 12 equals 4 times 6, and that works out 24 is 24, so that's all right. And then using -12, so I've got 2 times -2, plugging that in there, plus 12 equals 4 times -2. So this will be -4 plus 12 will be 8, but then over here I get -8. So this is actually an extraneous solution. We can't claim that as a solution to this absolute value. There are essentially 4 different things that can happen with absolute values, and that's what's kind of in this table. So you can have your absolute value be less than something, be less than or equal, be greater than, or be greater than or equal. Those are kind of the 4 things that can happen. So I'm just going to show you what the equivalent form means is almost what the equation would be that you would solve. And then the graph of the solution, I'll just give you a sketch of what that would look like. So if you have this basic less than situation, what you've got is -c, you've got that one, and you're kind of sandwiching your expression in the middle. So either you're going to be less than the positive value, or you're going to be greater than the negative value, in there somewhere. Same idea happens with the less than or equal to. You keep your stuff kind of sandwiched in the middle, and you just got your less than or equal to signs there. So what that would look like is you would just have your two values, whatever you found, they would be open because you're only less thans, and you would be in the middle. The other one would just have filled in circles, and you would still be shading in the middle. Then you've got these two guys, and these are or statements. So when we're doing a greater than, we're going to do that ax plus b is less than negative c. We'll do the negatives first because we read left to right. Or you can have ax plus b being greater than c. So those two things can happen. Either you're less than this guy, because remember absolute value will turn you positive, and you're looking for things bigger than that number, or you're going to be greater than that number the way it is. And then the same thing, you just happen to have the equal sign. So we'll be less than or equal to negative c, or, I'm going to kind of highlight that, ax plus b is less than or equal to c. So what does that look like? These are the ones that go away from each other. So this one, because it's a greater than or a less than, it'll just be open, and we're either that way or we're this way. The other one is just with filled in circles, but still going in the same direction. So those are kind of the 4 different things that can happen. These two are really very similar. They're pretty much the same thing, just whether or not your open circles are closed. And then these guys, when they're greater than, they split into 2, and they really are the same thing, except just whether you're open or closed. Okay. So let's try a couple, and then we will call it a day. So the first one is 4x plus 5 is greater than 13. So since we are greater than, that's actually a two-parter. So sorry, we're going to split it apart, make our 2 or statements. So I got 4x plus 5, and either you are going to be less than negative 13, or you are going to be greater than 13. So you've got the original statement, that's one of them, and then you flip the sign and make it negative for the other one. So you're looking for all the things that could be greater than 13. And remember, absolute value will turn it positive. So negative 14 would be valid here, because the absolute value of that would be positive 14, and that would be good. So any negative numbers smaller or to the left of negative 13 will work. So that's why we do a less than. So let's just solve each of these up. I've got 4x, and I subtract 5, I get negative 18, and then divide by 4, I end up with 9.5, or about 4.5. This one will subtract 5, and we'll get 8, and then when we divide by 4, we'll get 2. So when we graph both of those, I'll throw a 0 in here, and here is 2 for me, and we're going greater than. And then to go the other way, this is negative 4.5, so 1, 2, 3, 4, about 4.5 right there. And that is also an open circle, and then I'm shading that way. So any of those values outside of 2 and outside of, I should put 4.5, will make this work, because then they will be greater than 13. Last one for today, we've got a 2x plus 1, and then this time we are less than 9. Excuse me, my voice is getting so scratchy. So we are less than, so we're setting up our 2 statements like this, our 2 ors. Sorry, less than. This is the statement we want, my bad. So we're going to go negative 9 less than or equal to 2x plus 1 less than or equal to 9. So we're just sandwiching that thing in the middle of those 2 9s. So subtracting 1 will give us negative 10 and 8, and then dividing by 2 we'll get negative 5 and 4. So I'm going to put my 0 in there. 1, 2, 3, 4, big filled in circle. 1, 2, 3, 4, 5, filled in circle, and then I want everything in the middle. So I think overall this chart's going to come in really handy, just deciding what you're going to do. Keep in mind that these two are truly the same, and these two are truly the same. It's just a change in the sign.